Hello everyone and welcome to this video. This video is part of our ShadowMe project, which is a series of videos and labs shadowing a malware analyst or an investigator. My name is Ali Hadi and I will be your instructor for this lab. So in this lab, what we will be doing is continuing our analysis of this malware, why do this, or whatever it's called. And we made a copy of it so we can kind of run it in this lab. We're going to focus mostly on the dynamic analysis part of it, but let's just kind of quickly go over uh, a couple of the functions again, just as a reminder, and make sure that we kind of know what this sample is doing, or at least have an idea of what this sample is doing. So let's leave it to run a little bit. As you can see, PE Studio is running some analysis on the sample and doing some detections. We can also use Kpa or other tools as well. This is just one way to do it. And also whatever we will be covering in the video is just also one way of doing things. It does not mean there are no other web method or approach to do this. It's just one way. It's up to you later to decide how you would like to approach this. So as we can see here, it's an exe from the MZ header. We can see also from here saying the file type is an exe. It's a 64-bit application, or it's targeting it's being compiled for 64-bit systems. We can see the compiler timestamp, etc. We can also see a couple of indicators. These were all kind of pulled automatically by PE Studio, and as you can see here, PE Studio will give you like the level of like each one of these, like how severe they are, etc. So it kind of adds a level to this, and as you can see, a couple of details in here about the sample. Now I would like to mention, by the way, that the version that comes with the Flare VM might be a little bit old, so if possibly you go ahead and let's say download the latest one. So I think I did do that, and I might have stored it somewhere. So in case you haven't, by the way, all you need to do is just go to PE Studio's website, okay, and download the newer version, because I'll show you in a little bit. There is probably going to be some slight differences in there. So it's already downloaded. That's good. So quickly, let's extract. And if we go here, PE Studio, let's load, and I'm going to minimize this. Now let me go to the sample. Just load it again. So you might find there's a little bit of differences. As you can see, this is 9.20, while this is 9.59. And the tool is just getting better and better. The developer, shout out to him, doing a lot of updates and making the tool much better. As you can see here, even some kind of, as you can see, categorization. So there, it is worth always to keep, by the way, 2 copies of like a tool. I've seen this multiple times, that maybe you get used to a tool and a feature in it, and then it gets updated, and then that feature gets removed or updated, so you no longer have the same way of doing things. So it's always kind of handy to maybe have a copy of an older version. That also depends on you. It's really up to you. It's not like it's a must. Now, as we can see here, it's getting analyzed, and the indicators now are done. As you can see, now the level looks a little bit different than here. We had level 1, 2, 3. Now we can see it's kind of like pluses, and you can see each one of them is explaining why probably like this is being flagged or whatever as an indicator. One of the things probably like we can look at this, or like maybe check out here, is like the URL. We can see there's a URL to some image located somewhere on the internet. We can see that these are probably like the functions being used or the Windows APIs being used. So we'll probably need to keep an eye out for those. We can see that the malware or the sample is using URL mon, and it's using also WinInet. So URL mon is for URL operations, kind of to communicate with remote servers, download files, etc. And then WinInet is usually to take advantage of like internet-based tasks and like sending HTTP requests and accessing web servers, etc. So it's kind of like that's what is going on over here. It says, let's go ahead to the library. So as we can see again, we talked about the URL mon, which is for URL operations. Okay, so maybe to download some like files, resources from the internet. WinInet for handling HTTP requests. So anything internet-based also is kind of used over here. Then we have user 32. We'll see what functions are there. So if we go to the imports, now we can see like the functions and where are they being pulled from. So as you can see here, it's telling you from which library these are being pulled from. Maybe let me maximize this so we can have a clear view of this. So we can see all of this going on. A couple of things that, as you can see here, internet open URL to open a URL. If we can look down here, we can see write file, write process. So write file probably to deal with some file operations. So we can keep an eye out that maybe some file operations are going to be used here in this malware sample. We can see find next file and find first file. So probably doing some search for files, create file, as you can see over here. What else can we see? There's a lot, by the way. I'm not going to go over all of them, but I'm kind of trying to URL download to file. We can see it's to download a file from the internet to the system. Virtual alloc EX is to maybe create some memory space in a remote process. So usually that's used with maybe some injection. So these are kind of just indicators. These are kind of things you need to keep in mind when doing some malware analysis. We can see the terminate process, open process, so it's opening probably like a process. Create tool help 32 snapshot, so it's probably going to be used, and as you can see here, process 32, so it's probably going to be used to kind of create a snapshot of all the running processes currently on the system, and then to cycle through them, probably targeting a specific or a certain process. So create a snapshot, then cycle through them, find the process, and then do something to it. So these are all different APIs which are available, and then it's telling you, or from these we can kind of have an idea of probably what's going to be done or what's going to be used. So as you can see here, by the way, open process is telling you this is probably going to be used for process injection. Create tool hub for process discovery, because again, probably to circle at the system and try to discover some processes. Process 32, again, part of the discovery. Process injection, which is create remote thread, to create a thread in the remote process. Process injection. We can also see the sleep is probably going to be used for sandbox evasion. So maybe the malware, once you run it, it will sleep, kind of to just evade the sandbox, especially if a sandbox was configured kind of like to monitor the process activity within 5 minutes or 10 minutes or whatever. These are methods that might be used for bypassing the sandbox or any kind of detection. So we, as you can see here, we can grab a lot of information by just looking at this. So you'll need to spend some time on this and make sure that, let's say, you understand what's going on, have an idea. The strings are also going to be very useful to you, so make sure you kind of spend some time on the strings. What type of strings am I seeing in here? There are multiple ways to kind of find these strings, sort them. As you can see here, here is our URL, which is kind of weird. We can find, actually, we can see the findme.png. We can see a file called luls.exe, or like a name called luls.exe. We can also see Notepad is being referenced, Explorer.exe is being referenced, x.zip is being referenced, Procmon, Wireshark. So it seems it's referencing a couple of like malware analyst tools. So probably maybe these are going to be targeted. We will see in a little bit. So again, spend some time on the strings to make sure you understand them and then kind of start searching for them. Because for example, we will need to search for like Notepad, or maybe search for this findme2.png, the lulz.exe. So it's maybe some activities going on, the x.zip. So those are kind of going to be helpful to us when we do our uh, dynamic analysis. So let's go ahead and close this. Now this should be done. And what we will do now is I'm going to, like I said, I made a copy. So this time we are going to run the sample. So let's go ahead and make sure we, before we execute, we get our tools ready. So one of the things that I'm going to get ready is our process explorer. So I'll run it with admin to make sure kind of to monitor what's going on. You can also use process hacker if you want. So process hacker. So again, run it as admin. And this is kind of to just be able to see what processes are going to be created or happening when I run the malware sample. So when I will run it, what processes are going to be created. I can probably have a visual view or a quick view over here. Now, this is definitely not what I'm going to depend on, but again, excuse me, just to keep an eye out for what's going on. Now I'm going to use Procmon, and then in future videos will show how to make usage of Procmon much more simpler. But for now, let's just go with the basic and step by step and gradually learn and get better at using these tools. So at the beginning, as you can see, Procmon is capturing all of those events which are happening on your system. So even if you think you're not doing anything, your system is still operating and doing some activity in the background. So that's why Procmon is kind of listing them. Now, as you can see, it's telling you I'm only showing you 38,000 while we have 219,000 something plus plus. As you can see, they are just growing. So what I like to do is stop the capture. I like also to clear that, so kind of minimize the number of events that I have. And then what I will do is I will use the malware sample name and put a filter on it. So I'll go here on the funnel, this icon again, this icon, click on it. Then on this drop down list, I'll go to process name, and the process name, the condition here is going to be is this, and then I want to include this. So if I add, as you can see, this is now marked in green because I want this to be included and not excluded from my results. Now I hit apply, and now I hit OK, and now I go back and I can go back and do the capture. Now it's capturing, but there is nothing to be displayed. Why? Because again, what happened is we didn't, like, it's monitoring for that name or that process with that specific name, and then that process has not been started yet, or it's not running yet. So what we can do, again, pause this, clear this, and I'll tell you why. So what I'm going to do also now is run Wireshark. You can use, by the way, again, we'll probably show in the future other ways of doing this, because you don't have to use Wireshark. You can use whatever method or whatever traffic capturing method you want. You might have a separate system, by the way, to monitor the traffic, so it's not on the main analyst system. You might have like a network set up where you have another system capturing network traffic, like maybe you have Security Onion or any other system with different network monitoring tools. But for this video, we are going to use Wireshark. So as we go to the capture and make sure we have like the Ethernet, that the one is our like the default one. So make sure we have that. And then as you can see, enable promiscuous mode. That's very important. And I'm going to hit start now. It's probably going to be, yeah, let's just do this for now. So now we are going to be monitoring the network traffic. So we can see now it started to monitor some network traffic. Now what I'm going to do, I'm going to start the capture. As you can see here, no capture disabled, no events. So let me just double check this. Okay, so Procmon just kind of bailed on me. I don't know why. So I had to restart Procmon. Now I started Procmon. It is going to be filtering any activity related to this malware sample that we have. And now I'm going to go ahead and do what? Start the malware sample. So if I go there, start the malware now, as you can see, what happened is it went ahead and it kind of terminated all of the processes that I have, and now it's making fun of me, saying close me if you can, or whatever. So as you can see here, every time I close it, it's doing this, and it, like, as you can see, it caused all of my processes to terminate. So process hacker was stopped. And as you can see now, if we scroll down, probably we can see we have this lulz.exe running somewhere. We can see the path from by just hovering it in process hacker, and we can see this exe. So as you can see here, probably if we stop this, so if we terminate it, by the way, it's probably this executable. And as you can see what it did, it also opened some websites. So again, this malware sample was programmed in a way for educational purposes, and that's why it's opening this website, because that's what we did. And as you can see here, it seems that the malware sample is going to continuously probably just continue opening this website. So if we probably pause for a little bit, okay, I'm going to pause the recording just a little bit until like the sample opens the website again. Okay, so as you can see here, it opened the website again. So it seems every time, like probably that we need to find out how many minutes it's doing this, or every minute or whatever, and we can find that probably later. But it seems every time after a while, it just keeps opening some website. Okay, so now, by the way, what happened is one, we can see it targeted our tools. So our tools were kind of disrupted and closed. So when we were looking and we saw that tool, the snapshot thing and the find process next, whatever, we said that probably the sample is looking for a certain process and then doing something. So it seems that the snapshot was created, or at least that's kind of our hypothesis based on what we saw currently. So it seems the sample is being searching for those processes and then terminating them. As you can see, it's going to just continue to do this. Now, what we need to do is now, in this case, especially that this is an active sample, by the way, what we need to do is we need to restore our VM to like our previous state or a clean state, and then go through the analysis again. But this time, we'll see how we can bypass those like methods that this sample is using. There are so many ways to, by the way, bypass probably this anti-analysis thing that this sample is applying, but we're going to show a basic one in this case, and then moving forward in our ShadowMe project labs, we will show more techniques and different methods that we can use to kind of avoid this type of behavior and not let our tools be disrupted. So let's go ahead. I'm going to pause the video. I'm going to restart my snapshot, and then we'll continue from there. Okay, so we've restored our VM now. Let's continue and see how are we going to kind of, let's say, avoid our tools being crashed or detected and then terminated. So what I'm going to do in this case today is, let's just rename this to exe again. And before we run it, what I'm going to do, so Flare has all of the tools, by the way. So the utilities we are looking for is like the Procmon, right? So Procmon or any of these, by the way, if you right click on it and say go to open file location, you can see they are over here because they've been installed by Chocolatey. So if you probably like check the script that Flare installation does, it uses chocolatey for this. Now, one of the basic ways that I'm going to use for like bypassing this is I'm just going to rename these tools. So I'm going to create a copy of Procmon. I'm going to call it P64. Excuse me. And then I'm going to also create a copy of Process Explorer. And name it PE64. We can also, by the way, do the same with Wireshark. The good thing is we can still do that. So you can see Wireshark is over here. I'm going to create a copy of it, and I'm going to call it WS. Okay, let's leave all of these like this for now. And then what I'm going to do now is let's start the Process Explorer, but the new one, or at least a copy, which is not using the Process Explorer name. It's PE64. That's one. Let's also start our Procmon, and then we can pause the capture. So we have no captures yet. Okay, let's minimize this for now. And also let's start our Wireshark. So if we go to Wireshark over here, we're going to start this copy. So, and then capture. And then, yeah, let's do capture this and then start. Okay, so starting the capture, all of this is ready. So Wireshark is done, this is done. Let's use the name, put a filter. Let's go ahead again, process name, filter, add, and now as you can see, we want this to be included. Apply, okay, and then let's start our capture. So you can see now the capture is working. And let's now go ahead and run, make sure everything is ready. And then now let's go ahead and run our sample. So if you're ready, everything is good to go, hit the run. So we're going to do that. And the reason, by the way, we run it with like administrator privileges is we want to test like its full capabilities. Like if your goal is to test the sample and see what can it do, then probably running it with admin is the best. But if your goal is probably to run the sample and test like a user account and see what kind of damage will happen if you are running it with a certain user account, then you run it with that user context because your goal is kind of different. But in our goal here to do malware analysis, we actually want to know exactly what this sample is doing. And that's why we will give it admin. Now, as you can see over here, our tools, none of them were stopped this time. So our sample is running, everything is okay. Process monitor has captured a lot of different activity going on. And if we kind of keep an eye out, we can see that the browser is just going to continue to open the website. So it seems everything now is running, and as expected, our tools are working. We didn't get kind of disrupted by the sample and so on and so forth. So now we can start our analysis. As you can see here, we can see the exe, and we can actually, even if we double click on it, we can see where the path, where is it actually running from. So we can see it's running from the user application data, like this username, application data local temp, and then this is where it's from. We can probably even go there, and we can see that the executable is over here. So let's keep this probably available over here. We can see the name of the executable. We can see a lot of different things. Probably this is for another video or whatever, and we can see if we bring it to front. So even if it was in the back, let's do this probably and bring it to front. This will show it to us, so we know that this is this executable. This won't, by the way, work all the time, but it does in cases where the executable is running within this session and then this desktop. Let's call it like that for now. If we go to strings, we can see these are the strings which are being pulled from the executable, similar to what we saw when we were running our strings. If we go to memory, these are the close me, we can see these are the strings that are being showed in the memory, okay, of the application. So let's close this, let's minimize this, we don't need it anymore, or at least for now. And now what we can do is start our analysis on using procmon. So we can see the first column is about the timestamp, the second is the process name, the third here is the process ID, and then we can see the operation that happened, what type of operation, whether it's a process operation. This is going to be continue to be annoying, I know. Whether it's a process operation, whether it's a file operation, a registry operation, and so on and so forth. Where has this operation been applied to, or where was it running a file, opening a file, whatever, and then was the result like successful, not successful, found, not found, etc. We'll see a lot of these operations as we go through, and then finally we can see the detail of this operation. So if we look at this, for example, we can see that the file system created a file which is the prefetch file for why do this. So the exe, once it was started, the system went and gonna create a prefetch file. So as you can see here, the result was name not found, and what the system will do, as when we create any file, the system will first check, is this file available already there? If it is, then the system will tell you, hey, this file already exists, so you need to kind of use a different file name. And so this is checking and saying, okay, the file is not there. And as you can see after that, probably if we check, you'll see then the file then got created. So probably if we kind of continue looking down the line, we will see then the file was created. We'll probably see that in a little bit when we do some more filtering. For now, I just want to go over this very quickly, or at least give you a quick idea. Now, what are these buttons are the different types of like events which are going on, or like as you can see, this one is to show you the activity related to the registry. This one is for the file system. This one's for network activity, and then finally this one is for process and thread activity. So if we go ahead, for example, and click on this, so as you can see here, now all of the registry activity has been kind of not displayed to you, so they are no longer showed. So if I bring this back, by the way, we have here 13,000 plus of events. Now, by the way, one of the things that I'm going to do today is I'm going to pause my capture. I don't want to capture any more traffic or events, because it seems what this is doing is continuously and annoyingly just opening this web page, and it's just going to add more events, and like it seems there is nothing there, at least for now. We can assume that. And again, it was programmed by us, so we know really what it does. And again, it's for like educational purposes. So if we go again and like remove this, so we can see now we only have 1,900 something of events. If we, let's say, go ahead and remove the file system activity, we can see we only have 108 operations or activity showing for like process and thread activity. Okay, so we only have those. So as you can see, we can minimize our filters, by the way, based on like what activity do I want to focus on. Okay, now they are all important, so we need to understand how to filter through this. Okay, so let's keep this in mind. So they are all important. We need to be able to understand how to kind of filter through this, apply some filters to make sure we can find what we want very quickly and efficiently. Now, another thing what we can do is, when this is to kind of give you an overview of Process Monitor, but what you can do, or what you can start with probably, is go to Tools and go to Process Tree. This is a really cool feature in Process Monitor. Now, if we go to the application or the malware sample that we run, as you can see here, this is why do this, and then it created the con host for creating like a host for these executables. And then so it seems why do this created the lulz.exe, so we can see that Probably let me expand this a little bit so we can see some further details. Okay, let me do this, maybe like this. Okay, and then we look at the command and the details probably in a little bit. And then we can see cmd.exe was also used, and the cmd.exe, we can see that it was used to run this. So this is the command that was used. So that's why we see ping.exe as a child or a sub-process of cmd.exe, because cmd.exe called ping to the local host, and then it used this to delete the executable. Now, this is a method that threat actors will use to kind of delete the executable to clear their tracks. Okay, so it could be done like this. There are other methods, but not, this is not the only one, but this is kind of a normal or a kind of a like very commonly used way to delete the executable. Now, as you can see here, the lulz.exe, this is running out of this location. So we now know that why do this? Lulz, CMD, and the ping are all part of the same process. Okay, they are all part of the same process over here. Now, let's go ahead and do something in here. So what I'm going to do is I want to make sure that we also see, so we don't want to now just focus on why do this, because these are other executables that might have been used to do something. So we need to include them in our filter. As you can see here, the filter is only for why do this. Excuse me. So let's go ahead and now right click on this and say add process and children to include filter. So if we do that now, okay, and close this, we probably don't see any of those other processes being added. I'll explain why in a little bit. And it seems I probably, this is my assumption, I could be wrong, but it seems that process monitor will not be able to kind of mix between filtering based on the process ID and the process name. So what I would usually do is right click, include them, and then I will come back and I will remove, untick the process name, and then just hit the apply. And now, by the way, I can see the why do this, the executable, but I can also see the other processes that were created by this executable. As you can see here, let me scroll down a little bit to show you. I know this is going to be continuously annoying, like I told you. And we could probably see, yeah, we can see the ping, we can see the CMD, etc. So it's up to you, but this is one way of doing that. And we now can see the process and all of the sub processes that happened by this executable. Okay, now sometimes, by the way, what you can do is also you can right click here and say, hey, this path, I don't want this. So you can say exclude this path. That's really up to you. There are so many different ways to kind of filter and narrow down and get to your the results that you want. And again, in future videos, we will show other methods of doing this. But for now, let's go ahead and look at this executable in like a, let's say the basic way, or again, step by step, adding more techniques to our arsenal later. Now, what I would like to do usually is look at what files have been created, dropped, etc. So I don't need, by the way, the process, probably. I don't need the registry activity, so I'm going to remove them. And as you can see, this narrowed down our list of events to 2,600 something. So it's still a lot, by the way, to kind of, if you're thinking that, oh yeah, I'm going to go one by one through all of this, good luck with doing that. Probably you will end up finishing after like probably a year. I don't know how fast you are. But again, that's not the best way to do this. And as you can see here, we have a lot of different operations, a lot of files which are being accessed, checked, used, etc. Because every time we saw this, we already saw this in the executable. The executable will be referencing libraries, excuse me, because it needs APIs and functions within those libraries. And it also, those libraries might be referencing other libraries. So because they are depending on other libraries. So even though your executable is depending on one library, that doesn't mean other libraries are not going to be included because it might call those libraries. So again, it's a lot. It's a lot of activity in here that's going to be listed. Now, again, what you could do if you know that, let's say, I don't want this OLE32 library to be show up in my events. What you can do is right click and say exclude this library. So exclude this. Now this is going to narrow things down. As you can see, we came down to 2600 exactly. That's kind of really lucky that we went to like an exact number like that. And again, it's really up to you what you think you won't need. Like you might say, oh, probably I don't need ntdll.dll. And then what you can do is just say again, right click and say exclude. So you might say that. It's really up to you. And by the way, sometimes it's a trial and error. As you can see, that one didn't take a lot. It only kind of took out 16 events from our list. But again, it is now, we are narrowing down the amount of usage or list of displaying those events. Now, let's go ahead and look for files that have been created. So you might say, how am I going to look for files that have been created? We're going to go and add a filter. So we get back to the funnel. And then in here, what we are going to do is we are going to go to operation. And the operation is create file. And by the way, if you just kind of, I just when I wrote create, by the way, I use my down arrow on my keyboard, and it automatically brought this to me. Now, if you list the drop down, as you can see, there's a lot of like operations which have been already configured for you. So if now we want this, so we want create file. So let's add that and hit apply. Okay. Now it kind of brought us down to 606, which is kind of nice because it's not lot of files are listed now, and probably we can like skim through them and look at them. But let's go ahead and add one more thing. I like to add one more thing to this. So what I'm going to do is go here, and let me probably not this one. I want the yeah, open result. So see this, I'm going to copy it. And again, I'm going to go here. So I'm going to go to the detail. And then instead of is, I'm going to say contains. And this time it's not opened. I'm going to say created. Okay, I'm going to add created, apply. And there you go. These were the files, by the way, that were created. Let me expand this maybe, and maybe do this and maybe do this so we can expand this. Okay, so these were the files, by the way, that have been created by the why do this file or the why do this sample. Now look at this. We can see these are from the cache, from the internet cache. So when it was downloading the file, so we know these are part of the cache. We can see that the file is 7-zip whatever. So it probably downloaded 7-zip to do something. Probably there is some compression, or there's a file compressed in there and it's kind of downloading it. To do that, we need to do further investigation. But a nice cool thing is if we right click and say jump to, it will take us, by the way, to where this is located. And as you can see here, we can see that this is the exe, and we can probably just go ahead and validate this. Like, for example, you can easily validate this, like get the hash value. So probably like the SHA-1 of this some exe, and validate this SHA-1 with the 7-zip SHA-1. If they are the same, then probably this malware just downloaded 7-zip for some reason we don't know yet. And then we can see that there is this x.zip file. Again, jump to, it should take us there. So we can see this x.zip file. Probably you can go ahead and like extract it and see the file is open or whatever. So it failed to execute or extract the file. Oh, and see probably like this is 7-zip. So it's probably the 7-zip, like the software itself. And again, you can double check this, or probably if we check the SHA-1 again, and if we check the other SHA-1 which we just saw, maybe now. So SHA-1, okay. We can see that they match. So this is, by the way, the 7-zip. It has just been renamed, probably to fool the analyst. We don't know yet, but probably that's what's going on. We can kind of, our hypothesis say this is kind of fooling or trolling with the analyst. Then if we look at these are caches, we can see that this is an image there. Okay, we can, so if we go there, we can see that this image probably from like when we had this event. Okay, so it's an image there. We can see this g.zip as well. If we go there again, we can see that there is some file over here, and probably let's see if we can extract this. It's not an archive, so probably something else. We need to investigate that. Okay, we need to investigate this. This is going to take some time. We can also see, by the way, the find me when it first landed on the system. So we can see this find me image. So if we double click on it, we can see find me if you can. Again, some trolling with us. And we can see also it's over here. So if we go there, again, all of this, just one filter or two filters actually. And those two filters kind of showed me all of the files that happened on the system. Is there an easier way to do this? The answer is yes. We'll show that in future videos. But for now, let's just use this and kind of learn how to do this this way. Again, find me the, and we can check again. We can see the sample is over here as well. And SHA-1, so this is the SHA-1 of this image. And then if we do a SHA-1 over here, excuse me, let's minimize this. So we could probably see that they are both the same. So it's what that means is probably the first one that we saw, the one over here with the brackets and whatever, this is part of the cache, and it actually is, because as you can see, it was downloaded by Microsoft Windows or whatever, Windows libraries, and then it got copied over probably over here. So we can see that. Let's go back here. Okay, and then we can see this thing. We don't know what this is. If we go to jump to, so it's not there, by the way. It seems this has been deleted. So when you do jump to and you don't find it, then probably this has been deleted, or probably what this is, by the way, also sometimes it really depends, and we need to maybe dig deeper, is this is when the temporary file name gets assigned. So this is a kind of a random temporary file name. And then after that, this is the file name that gets created. So if we go there now, we can see the lulz.exe, and this is probably this exe, or actually it is the one that has been trolling with us for a while. Okay, so that's what's going on. But there's another cool thing here. Excuse me. We can see here we have this DLL, which has been also created by Why Do This. So this DLL, by the way, has been created by this exe, Why Do This, and we can see the date modified. By the way, it automatic, or I would say it immediately shows like this has been modified back in 2021, which is kind of weird that this also was created. And if we probably like check the properties here, we can see that it was created back in November 19, 2021, which is kind of weird because we can see that it was created today when we are doing this video recording. Okay, and we can see today is October 6, 2024. So there's something weird going on. We need to check that and investigate that. We will do a deeper dive in future videos, but for today, let's just use Procmon and the sysinternal tools to kind of have an idea what's going on. So we now know that first we have our 7-zip was downloaded, renamed to x.zip, or at least a copy of it. gzip, we don't know what that is yet. There's some image, which is this. We just know that it's an image. We can see this find me too. got copied over to find me to in the wherever the executable was run. We can see a lools.exe was created in the or dropped or whatever in the temps directory under application data local. We can also see this full dia.dll was created under system 32. So there is a lot of like weird stuff going on. Let's go ahead now. So what I would recommend, by the way, you do is either document this, maybe take a like a snapshot of it. So like use a tool like a snippet tool, or maybe snip and sketch. It's really up to you. But document this definitely. And for example, like we'll do this. Okay. And add it kind of to your document. So if you're using WordPad, whatever, I think we can use WordPad on this system. But definitely if you're using something else, just add it to your like documentation so you can come back and use it. So it's kind of creating your technical notes because we'll need them later on when we are going to be creating our report. Again, and also probably what you can do is also export these or save them. So if you want to say, hey, I want to just like save only these and like in like comma separated values, let's kind of store them or save them on my desktop. So for now, it's just again to show you a couple of ways of doing things. So we are going to only the ones event displayed, store. So if I go now and open this, for example, with Notepad, if we go ahead and open it with Notepad, we can see the events that we were looking at, and then we can use this details later on, probably like in our report if we need that. Okay, so it's really up to you how you do this. So let's continue, and I'm going to close these. I don't want them for now. I think we already have a lot of windows open. We don't know, we need more windows open. I'm also going to, by the way, close this. We don't need to continue to capture. But for example, one of the things that you can do is quickly look at what are the DNS traffic or what locations did this like malware look at. We can see it was looking at the GitHub usercontent.com, and we saw that actually in the string, the long URL. We can see 7-zip like website was accessed. We can also see like the blog, Cyber5W's blog is accessed, and so on and so forth. Then but everything else, by the way, is probably going to be encrypted. So we didn't kind of, we probably won't get a lot of details from here, especially with just looking at Wireshark, but we can still get a lot of especially if the traffic is encrypted, by the way. But we can still get a lot of info from this metadata, which has been used or is part of the traffic that has happened. So again, what you could probably do is like save this PCAP file wherever you really want. Okay, so call it why do this. Okay, and then just save it wherever you want. Okay, because then later on we can process this and look at that. Now, if we continue, go back to our process monitor. Let's now go ahead and we know we have this one we need to look at. We know that we have the rules one we need to look at. Let's kind of check the registry entry. So if we, let's say, remove this and add the registry, but as you can see, nothing's being displayed because our filter is now not going to help us with that because we are looking at create files which are not registry operations. So let's remove those, exclude them. So now we have registry events, but this time let's add some registry events. So if we go down here and say operation is, so usually what happens, maybe let's say a malware creates a registry key for some persistent method or for persistent mechanism to be used. What we could do here is check for the reg events. So if we, again, what I did is just type reg and then with my my down arrow key, I get to those registry events. And now if I kind of do this drop down list, I can see all of the reg events which are available. So you can see reg close key, reg create key, reg delete key, etc. Excuse me. Now what we need, or what I want to look at, is I want to look at reg set value. So I want to look at that and see, did this malware sample create any registry values? So if I do this, we can see that this malware created these registry entries. Now, probably some of them, by the way, were part of like the uh, the Internet Explorer APIs, which are being used to download the sample. So as you can see here, the zone map, proxy bypass. Now those were accessed and used. But by the way, probably we can see here not many of these events are really useful. So not many of these events, by the way, are useful. We can probably just see this, which is part of BAM. We can talk about BAM in future videos, but this is to track the process activity. So we can see that an entry was created in the registry, which is part of the system to track process activity and behavior, like running on the system. But I don't see here anything kind of important for registry activity. You could probably say, what about keys? So what we can do is, again, go down here, click operation, and then say reg, let's put the down arrow, and then create key. So we can select this one, create key, apply now, and we can see no, oh, actually there are some keys which have been created. But again, probably, by the way, these keys are all related to the normal behavior of accessing the internet and the network, as you can see here. And so they are really not that much important, especially in this case. So what I'm going to do is I'm going to exclude them. And it seems we do not have some important keys or registry activity going on. Now let's go ahead. I want to remove this. I want to bring this back, and I want to bring back my file operation. So create file and then the open result, because I want those back, and I'll tell you why. And I want to highlight this one. I want to highlight this. And now what I'm going to do is I'm going to remove these again. So I get all of the file operations, okay? But now I can see anywhere where that activity happened, like anything related to the foldia.dll. And now what I'm going to do now is I want to see, so it's a DLL. So why did this executable create or download or drop? We don't know yet, by the way. We have no idea yet, okay? But why did this happen? We need to find out. So what I want to do is I want to go now and look at the like the process activity. So I'm going to include the process activity, okay? And I want to see. So if let me just make sure we don't have any foldia over there. That's probably where it started when the foldia was created. Now what I'm going to do in this case is I want to see the operation loaded, because if this was loaded, then we should be able to see load image. We should be able to see a load image operation for foldia. So let's go ahead and add a filter here. So operation load image. Let's add that. Apply. So now we have much less. As you can see, we only have 194 of events, okay? And we should be able to see probably the foldia thing in here. So if we don't, which it seems we do not see it, by the way, let's make sure we have, okay, so this gets now interesting. This gets interesting, as you can see here. So the load image, we want to make sure, and let me just remove this again. And probably what I'm going to do is, because I saw I saw something going on somewhere. So I removed this anyway. let's go back to where that folder was available and search for it. So what we could do is full. Let's see if this will find it, by the way. Cannot find full. Maybe was that what we should be searching for? Or did I miss something? Let me quickly just search here. Okay. Yeah, here it is. Okay, okay. So we can see it back again, and we can see this. We can see folder, whatever, and then we no longer see anything related to it. So let's go back probably to our process tree and see what's going on. So if we come to this and look at the sample, we can see this, we can see this over here, we can see this over here, this, nothing out of the ordinary. We can see this has been run by Explorer, okay, but we don't see anything else from here. So now what we need to do, by the way, is go out of the scope of just looking at this, because it seems our filter, I'm sure this folder is being used, but the filter that we have now is kind of not helping us in seeing that. So let's do this. Let's exclude the processes, these. And then again, there's so many ways to do this, by the way. We'll do differently in other videos. For now, I'm going to do it this way. So let's exclude it. So now we are looking at a bigger picture. And now what I'm going to do is I'm going to bring back the load image one. So because I know probably this is going to be loaded, because why did this executable drop the exe, this DLL, if it's not going to be used? So let's assume it's going to be used. So now we are looking, by the way, at all the processes which are part of the capture. As you can see here, we have 1,300,000 something. I'm going to bring this load image again back one more time, apply, and now I'm going to see what's going on. So if we look down here, as you can see here, do you notice who has our folder loaded in there? So it seems explorer.exe, by the way, is the one that has now folder in there. So probably again, based on what we did on the analysis we've done so far, probably this DLL has got injected into explorer.exe, because explorer.exe now is loading the DLL. We can see it over here. Okay, this DLL has been loaded, and the load process or the operation was successful. Now we can also go back to Process Explorer and look at explorer.exe, come to view, show lower pane. We want to show the lower pane, this pane here, that's what it means. And then go to view again, and then in the lower pane, I want to look at the DLLs. So if we do that, and now kind of like maybe do the filtering based on the name. Actually, it's already filtered based on the name. So if we do that, and then I just hit the F keystroke, excuse me, on my keyboard. So it brought me down here. We can see the DLL has actually been loaded into the Explorer process address space. So we can see that folder has been loaded, excuse me, the folder has been loaded into the explorer.exe process. So it has been mapped into the explorer.exe. Let's go ahead. I want to show this as well using Process Hacker, because this is where Process Hacker really comes handy, kind of. Let's go here as admin, minimize this, go to explore.exe, and then if we go to the modules, so let's go here, expand this probably, and then let's see if I can hit F again. Yep, full dir. So if we go to this, okay, we can see that this is where its base address is located. Okay, this is where the base address is located. This is the size of this address. Okay, and if we double click on it, we can see it's an unverified library, or like a DLL, yes, and it's an executable. All of these details which we can see from here. We can see the sections of this executable. So it has a .text, rdata, etc. And then the imports, these are probably the imports from this DLL, okay? So there's a couple of things going on with this DLL. And if we go to memory, so if we go to memory now and kind of search for that, library. So let me, excuse me, search for it. Not sure if we can search. Let's just expand it like this. And probably what I'm going to do at the beginning, maybe just filter them like this, so I can see the path, whatever. And then let's see if we can see them and see the, like I want to see the protection on this. Sorry, I clicked on it again. Let's see, what do we have? I think now we are looking at them upside down. So let me scroll quickly down here. We should be able to see, because we saw it's running out of system 32. So yeah, as you can see here, this is where those sections have been mapped. Okay, as you can see, some of them have read write, some of them have read, and some of them have read and execute. So we can see that this DLL has been loaded and it's operating from there. Now, what does this DLL do? That's a different story, and that's going to be for another day, or for you to dig deeper and like go and do that. But for now, we know that this full DLL is something that has been created on the system. Now, we don't know for sure whether it was dropped or it was downloaded. We have no idea yet. We need to do some further analysis. But the basic things that we did so far at least showed us what executables, let's say what files were dropped on the system. It showed us a little bit about the operations that happened. So we saw the executable was deleted after that. We saw this image was created over there. We saw now that we have this DLL was created under the system32 directory, and it's being loaded into explorer.exe. We saw 7-zip was downloaded. We have no idea yet what was it used for. But again, with these tools, at least now you have an idea or a good starting point probably to what to do next. So the next thing to do probably would be to analyze these files that have been dropped. We saw the 7-zip. We confirmed probably that the x.zip and then the 7-zip executable thing are both the 7-zip. We now just probably need to confirm with the website that the hash is really for 7-zip. So it is 7-zip and not something else. That's one. We need to check the images. What are those images? Why it's being downloaded? Are they just to troll with us again, to like to fool us? We need to check those. This DLL, what is it doing? We have no idea what it's doing yet, but we can see it has been injected into, or it has been loaded, let's call it that way, into explorer.exe. So we have now other things to do and to take care of. Okay, but at least with these basic tools that we saw today, we were able to kind of find all of that. We were able to find these files downloaded. We saw what has been happening, basic filters using Procmon, how to do filters. There are so many other filters, by the way, that we can use and apply. We'll keep adding some filters. There are, again, lots of filters that you can use in Procmon. I'll even show you a way to automate the usage of Procmon in future videos. But for now, I think this is a good good enough for you to start and to continue the investigation of this why do this malware sample. In our next video, we'll take a step further, start looking in, let's say, either we will debug the sample or we will reverse engineer it. So our next step is going to be that, because as you can see, there are limitations to these tools. We were able to see what was created. We were able to see where were they created. We were able to see a lot of different things, but we need more solid proof of what's going on. And in order to do that, we need to dig deeper. In order to do that, we need to dig deeper. We saw this process created this process, this process loaded this DLL, etc. But we need more details of how this happened, what really happened in there. So that's what we will do in our next lab or in our next video in this ShadowMe project series. So that's it for today and for this lab. I hope you enjoyed it. I hope you learned something. If you have any feedback, if you have any comments, suggestions, things to be done better, things to be done, something you're interested in that you want us to show and write or create a ShadowMe lab for it, please let us know. Send us a feedback. And yeah, thank you for staying with us, and I hope you enjoyed it. Again, my name is Ali Hadi, and I will see you in future videos and labs. Thank you and have a good day.